Domestic water demand and supply assessment. In this video, we are going to learn how to do water demand and supply assessment for domestic purposes. Why do we need to do water demand and supply assessment? What is its importance? Assessment of water demand and supply helps us to estimate the existing gap between water demand and supply for the concerned population across different seasons. It can further help the stakeholders to plan for better water resource development and management practices. In order to understand the procedure of domestic water demand and supply assessment, let us take the example of a village, that is Chamling village, located in Aizawl district of Mizoram. From the social mapping exercise, we came to know that Chamling village has 65 households with a population of 323 people. Similarly, from resource mapping exercise, we gathered that the households are dependent on three natural springs. In addition to the springs, few villagers also depend on water collected through rooftop rainwater harvesting and supply of water through tankers, especially during the lean season. For a more detailed understanding of how to conduct social and resource mapping exercises, one can refer to our video film on participatory resource mapping for springshed management. In order to estimate the water demand of a particular village, it is mandatory to check the domestic water requirement as per the National Rural Drinking Water Program, that is NRDWP norm for the concerned area. In addition to this, we also need the social census data, that is the resident village population, as already mentioned in the previous slide. For the given example of Chamling village, NRDWP norm for Mizoram is 55 liters per capita per day. Considering the resident population of 323, the daily domestic water demand of Chamling village works out to be 17,765 liters per day. Next, we need to estimate water supply. To estimate the water supply of a particular village, we need to collect the discharge data of all the water sources along with supply hours. In case of villages dependent on springs, we will need spring discharge data of concerned sources across different seasons. Along with it, we also need to know for how many hours in a day the spring water is accessed or collected by the villagers. Spring discharge measurements are usually done in liters per minute, that is LPM. For details on discharge measurement of springs, one can refer to our video film on spring discharge measurement. For Chamling village, the table shows the discharge data of the three springs across the three seasons, summer, monsoon, and winter. For a particular season, one can calculate the water available from each source and then add them together to estimate the total water supply. In the example, the total water supply from the three springs work out to be 1920 liters per day during summer. Similar calculations can be done for the monsoon and winter seasons also. The water supply from different sources across different seasons can be graphically represented as shown here. The graph on the left-hand side shows the daily water availability from the three different springs of Chamling village separately during the three different seasons of summer, monsoon, and winter. It is clear from the graph that the water supply from all the springs is maximum during monsoon season as expected. The graph on the right-hand side shows the cumulative daily water availability from all the springs together across the three seasons. It can be seen that the daily water supply from the springs decreases from 14,400 liters in monsoon to mere 1,920 liters in summer. The computed daily water supply for a village can then be compared with daily domestic water requirements to check whether there is surplus or deficit of water. We had earlier estimated daily domestic water requirement of Jamling village as 17,765 liters. From the graph, we can clearly see that there is a gap between water supply and water demand in Jamling village throughout the year. The daily domestic water demand is much higher than the water supply, especially in the summer months, followed by winter and monsoon months. The water deficit in summer is as high as 15,845 liters. Discussions with the villagers of Chambering revealed that the above deficit is met through accessing water supply from tankers in the summers. Once we compute the domestic water demand and supply for a village, it can be shared with the concerned community who can further plan proper interventions to address the situation. For example, in case of Tamling village, the community decided to undertake sprinkler development activities to increase the discharge of springs. They also decided to promote installation of rooftop rainwater harvesting structures to store water during the monsoon season, in addition to reducing wastage of water, promoting recycling and proper water management. Thus, domestic water supply and demand assessment can help to plan appropriate interventions in a participatory manner among the concerned stakeholders. Thank you.